Now, we've worked with rational functions in the past. One thing that we have to be able to do with them is integrate rational functions. Now, we have looked at a basic skill to do with this, but I just wanted to talk about this one a little bit more in this video because it can get a little bit complex at times, but we should be able to break it down and make it a much simpler skill using previous skills that we've covered back in Unit 1. Now, we know sometimes we may be asked to integrate a rational function. We've covered that already. So that's a function that is the denominator of a fraction. So that's what we want in terms of our rational function to look like. Now, in order to do this, what we've talked about in the past is looking at the numerator and seeing if it is linked to the denominator through being a derivative. Now, a quick way to do that is look at the highest power in the numerator. If it's 1 less than the highest in the denominator, they're linked through a derivative somehow. Well, hopefully anyway. If we've got that, it's fairly straightforward to do. We know it's just a logarithm. F dashed over f of x dx equals ln f of x. However, what I want to delve into a little bit more is the fact that there may be cases where we need to use the partial fractions we covered before to split up the expression in order to do this. So I want to talk about that and show a couple of examples of how this would work. So let's start with an example here. So the integral of 5x plus 11 over x plus 1, x plus 3 dx. Now, first note is that if we look at this one, the denominator has distinct linear factors. So that's one of the 3 cases we can get with our partial fractions. First thing we have to do is use the correct format we talked about back when we did that to split it up. Once we split it up, we can integrate each term one by one to get our answer that we want. So let's look at splitting it up to begin with. So we know we've got 5x plus 11 over the denominator, so that's going to be over x plus 1 bracket x plus 3, and we want to split it into 2 fractions. We know if one fraction is going to be a over x plus 1, it's going to then be plus b over x plus 3. Now we know in order to do that, we multiply left and right side by the denominator of the left to get rid of that, and then we put in values for x so that we can find the a and the b. So what we want to change it into is 5x plus 11 equals a bracket x plus 3 plus b bracket x plus 1. So now that we've got that, we can substitute in a couple of specific values for x to then find the a and the b that satisfy that. Now, the quick and easy way to do this, substitute in a value for x that gets rid of each bracket one by one, and then we find it easily. So if we choose x equals negative 1, what that means, I'm going to have 5 times negative 1 plus 11. So 5 times negative 1 is negative 5 plus 11 is going to be 6. That's going to equal a times negative 1 plus 3, so that's 2, so 2a, but this whole term here disappears because I'm going to have negative 1 plus 1, which is 0. So because of that, I've got 6 equals 2a, no, I know that a equals 3. I could do similar for this second one here by choosing x equals negative 3. So if I take x equal to negative 3, I get negative 15 plus 11, so that gives me negative 4. This bracket will disappear. I've then got negative 3 plus 1, so I get negative 2b. What that then means is that b equals 2. Now, one point I want to highlight here. I've chosen x is negative 3 and x is negative 1. You don't have to necessarily do that. You can pick any values for x that you want in order to solve it. One thing to note, if you don't choose x is negative 3 or x is negative 1, what you'll end up with is some sort of simultaneous equation that you can solve for a and b. However, if I was to solve and find a or b on its own using one of these two, and then substitute in a random value for x, let's say x equals 0, I could still find the other unknown variable, the other a or b, just by working it through. It would just require a few more lines of working. Your values just don't matter, it just changes the complexity of what you're going to be working with. I prefer to do it this way, eliminate the brackets, just makes it quick and easy. Because now that I've got that, what I can do is I can change my integral into the integral of 3 over x plus 1 dx plus the integral of 2 over x plus 3 dx. Now if I take the number on the top outside. If I take 3 out here and multiply the integral by it, I've got 3 times the integral of 1 over x plus 1 dx. Well, 1 over x plus 1, the 1 is the derivative of the denominator there. So what I know is that that's going to be 3 times ln of x plus 1. And I can use the exact same logic on this one. If I take the 2 out as a common factor, I get 1 over x plus 3. So I then get 2 times ln of x plus 3. Then plus c. Don't forget your constant of integration. So there you go, distinct linear factors. It's not difficult, it's just the key thing, again, splitting up and remembering your a and your b here. The second type of partial fractions was when we had repeated linear factors. So we had this one here, for example, x minus 2 squared. I'm going to have a repeated linear factor there. Again, we still have to eliminate it and split it up into partial fractions. It just requires maybe an extra step or two for this one. So split it up. X squared minus 4x plus 13 over the denominator, so over x plus 1 x minus 2 squared. That's going to equal, and we do a fraction with each element on its own, so that's going to equal x, so a over x plus 1 plus b over x minus 2, and then a third one plus c over the x minus 2 squared. We always go up to the highest power. If this was a cubed, I'd do one more with x minus 2 cubed on the bottom. Then get rid of the denominator, same sort of way, multiply both sides by the denominator here. So what I'll end up with is x squared minus 4x plus 13 equals a bracket x minus 2 squared plus my b times x plus 1 x minus 2 then plus a c times the x plus 1. So I've got my expression written out like that. What I now need to do is the same as I did before. Pick values for x, substitute them in, eliminate variables and find my a, my b and my c. So if I start by, let's say, choosing x equals 2, what I'll end up getting is 2 squared, which is 4. Take away 4 times 2, so I get 4 minus 8, which is negative 4, plus 13, negative 4 plus 13 is 9. And if x is negative 2, the a and the b go, so I've then got c times 2 plus 1, which is 3, so that equals 3c. So if 3c is 9, I know from that c is equal to 3. If I then choose x equals negative 1, I'm going to eliminate my b and my c, and I'll be left with a to discover that. So I get negative 1 squared, which is 1. Take away 4 times negative 1, well, minus minus becomes a plus, so I've got 1 plus 4, which is 5, plus 13, which is 18. The b and the c go, and if I then substitute in here, I get minus 1 minus 2, so negative 3 squared is 9, so I get 9a. 9a is 18, a has to equal 2. Now at this point, you can choose any number for x that you want in order to get the final variable we need, the b. Make it as easy as you can. I'm going to choose x equals 0. All the x's go on this side, so I end up getting 13. That's going to then equal negative 2 squared, which is 4, but it's going to be 4 times a, which is 2. So 4 times 2 is 8. I'm then going to have my b, it's going to be 0 plus 1, which is 1. Then 0 take away 2 is negative 2, so it's going to be minus 2b. I'm then going to have c times 1, we know c is 3, so it's then going to be plus 3. So what I need to do is just sort it out a little bit here. So I've got 8 plus 3, which is 11. If I take that over here and do 13 minus 11, what I end up getting is that 2 is equal to negative 2b, so b equals negative 1. So what I can now do is split my integral up into 3 separate little integrals here, and then work them through from that. So I'll end up splitting it into the integral of a over x plus 1, so 2 over x plus 1 dx, plus the b over x minus 2, but that's then going to be minus the integral of 1 over x minus 2 dx. It's then going to be plus the integral of c, which is 3. Now it's over x minus 2 squared. What I'm going to do is bring that up and make it x minus 2 to the power of negative 2. The power on the bracket is higher than 1, so we can bring this up and integrate it as we would using a standard format. So this one here, 2 over x plus 1 dx, That becomes 2 times ln x plus 1. I've then got minus 1 over x minus 2 dx. So that's then going to be minus ln x minus 2. I've then got plus 3x minus 2 to the power of minus 2 dx. Well, that's going to then give me, raise the power, divide by the new power, I'm going to get minus 3 bracket x minus 2 to the minus 1. Minus 3 bracket x minus 2 to the minus 1, and then plus my constant c. Rewrite this with a positive power at the end. I get 2 ln x plus 1 minus ln x minus 2 minus 3 over x minus 2 plus c. So there you go. Integrated that second version using that technique there. Third version was the denominator having an irreducible quadratic factor. Again, separate it up using the form we know for that, and then integrate each term on its own. So we've got 2x squared plus 3x plus 5 over the x minus 1, x squared plus 4. That's going to equal a over x minus 1 plus, and this is where a slightly different format comes into play, bx plus c over x squared plus 4. Same drill as before, multiply by the denominator over here to get rid of the denominators on the right hand side, and what we end up getting is 2x squared plus 3x plus 5 equals a bracket x squared plus 4 plus bracket b x plus c times the x minus 1. So what I'm going to do now is pick values for x to help me get there. If I pick x equals 1, this term here goes. So if x is equal to 1, I've got 2 plus 3 plus 5, which is 10. That's then going to equal 1 plus 4a, so 5a. So I know that a is equal to 2. If I then choose, let's say x equal to 0, I'm going to end up with 5 on the left hand side. I'm going to end up with a times 4. Well, I know that a is 2, so it's going to be 2 4s, which are 8. But the b here is going to go. So I'm going to end up with c times negative 1, which is minus c. So if 5 equals 8 minus c, I know then that minus c is equal to negative 3. So c is equal to 3. Find the b now. Again, pick any value you want for x, and we're fine. So let's choose x equal to negative 1 this time. So I'm going to get 2 times 1 minus 3 plus 5. So 2 plus 5 is 7 minus 3 is 4. That's then going to equal 1 plus 4, which is 5. So 5a is going to be 10. I've then got plus in the bracket my bx minus c. So I'm going to end up with negative b plus c, which is plus 3. And then that's going to equal times negative 2. So what I now need to do is just sort this, and if I work this through, sort it all and simplify, what I actually end up getting is that b equals 0. So what I do, change my integral, I'll end up then with the integral of a over x minus 1, well a is 2, so 2 over x minus 1 dx. I've then got plus the integral of 3 over x squared plus 4 dx. Now, I can do both of these using standard forms. It might not look like it, but I can. This one here gives me 2 times ln of x minus 1. Now this one here can be written as the form 1 over x squared plus a squared. And we know the standard format for the integral of that is 1 over a tan minus 1 x over a plus c. So in this case, a squared is 4, so a is 2. So that's then going to give me plus 3 over 2 times tan minus 1 of x over 2, then plus c, so plus my constant of integration. So we can split it up using a variety of forms, and actually they tend to take the same format for the solution dependent upon the type of function that we begin with and the type of rational function that we have to separate up using our partial fractions. We tend to find, for example, this will contain some sort of inverse quadratic at the end. The previous one will contain a couple of logarithmic terms and a term that involves a power, and the first one will contain logarithms. So bear all of these in mind when you're working this through.